More on convection. A beautiful demonstration. I'm going to light a candle here. I'm going to light a candle. And here I'm going to, and it rests in a little saucer. I'm going to put this glass tube on top. And now no air can get in at the bottom, and the candle flame will soon expire. It will asphyxiate for want of air to breathe. Watch it. It's getting light. It's getting dimmer, dimmer, dimmer. Now I'm going to put in a partition. Watch it. Well, I'm having a little... There it is. There it is. It has been revived. It has been revived. Let me take it out, and I assure you the candle flame will go out without this partition. Watch it. Watch it. It's on the verge of going. It's on the verge of going out. On the verge of going out. Yeah, yeah, and I'll catch it now and give it a new lease on life. There it is. And what must we say? Well, the physics is clear. I put a partition in this chamber, in this chimney, so that cold air could fall down and the hot air come up. Now, don't ever say that hot air rises, because that ain't so. There ain't no Hindu levitation in this business. What happens is that the less dense air is pushed up by the colder air. Convection. Convection. Oh, a beautiful thing to witness. Have you not seen seagulls, especially seagulls, soaring at certain places in the sky? I once did this in class, and I'm led to tell you, I said to the class, how many see that I'm a bird on the wing? A bird on the wing. And one fellow, not so poetic-minded, said, Professor, you look quite like a vulture. I thought that was terrific. The fellow had an idea, didn't he? Right. All right. So much for convection. Actual transfer of heated stuff as compared with conduction, which is transfer of heat energy alone. Now, on an earlier program, I spoke about conduction and got a little cut off because of time. I want to go back to one of those experiments. Here is a metal hub from which emanates a number of spokes of different materials: brass, copper, iron, aluminum, zinc, nickel, and so on. And here is a wonderful experiment to do. Here's what I do. I take a little steel ball, and with a little bit of soft wax, fix a ball to the end of each rod. A ball to the end of each rod. Now what do? I apply some heat energy from a burner to the hub. The different rods conduct the heat energy at different rates, and obviously the little balls fall off in an inverse order to the conductivity. But an interesting question arises. I have here two identical kinds of rods, an iron rod, an iron rod. They are absolutely alike in their composition, but they differ as follows, and this is a wonderful exercise. They are identically long, but one is skinnier than the other. As a matter of fact, one has that diameter and the other that diameter. This is a diameter D and that's a diameter 2D. And the problem is as follows. Supposing I put a little ball on the end of each, and what do I have? I heat the hub. And in what order do they fall off? Well, I'm going to tell you. Let's look at them, because it's a very difficult problem. This has twice the diameter, therefore it has 4 times the cross-sectional area. 4 times. Therefore it conducts heat away 4 times as fast. But because it is twice the diameter, it has twice the circumference, and therefore it radiates from the surface at twice the rate. So this one does not gain over this one 4 times, but rather only 2 times. So what do? If I put a little ball on the end of this one, no, correction, in the middle of this one, and on the end of that one, they will fall off at the same time. And I hope I've said that correctly, but I got a little fouled up. Indeed, if I said it wrong, then you will write me a letter saying, Professor, what you said was not right. What you said was not right. Notice, I've got a little perspiration in my eye. That is a sort of saline, and it is not pleasant. More on this business of conduction. A wonderful demonstration which you can do. A silver dollar, nice and clean. You put it tightly under a handkerchief, so. Tightly under a handkerchief. There it is, tightly. Now, I wish I had a cigarette. We will imagine that I have a lighted cigarette. This piece of clothes on. Lighted cigarette. I put the lighted end of the cigarette tightly down on the handkerchief, on the coin. Question, what happens? Nothing. Why? Because the clean silver underneath takes the heat energy away, as it did in a certain experiment I did with a wood and metal rod, and the handkerchief is untouched. This is a beautiful little experiment to demonstrate to your kin. Enchanting. Enchanting. Next demonstration. This one you can do. Remember I said what happens first when you put a thermometer into hot water? It shows a diminution in the column. Take a flask like this, fill it with water, put some food coloring in it, fit it with a one-hole stopper in a glass tube, and the level is right here, more easily seen than the action of a thermometer. Submerge this in a vessel of hot water, and what do you see? Down it goes, for the reason that the glass vessel is heated first and expands. This concludes my recitation, and I thank you for listening.